All right, everybody, we are back. We are back. Announcements. First, I'm going to show you the grades. So yes, I have eliminated the people that are below 100 points are not going to show up. It's that 0 to 250. Those are people that are over 100 points. So I am going to drop the people that are below 100 points in the class, which there are a few. So I will be saying goodbye to them this week as nobody has responded to me. So here are the scores so far. So anybody in the yellow, the 750 to 1,000, if you don't see it as yellow, it's the 5 on the left-hand side. My two people above that, 1,000 and 1,250, I'm fully expecting you all to not have to take the final if you keep doing your work. As for everybody else, I'm pointing you on the camera, you have work to do. All right, that's all I want to say about the grades right now. 980 is a C, 1120 a B, and 1260 an A. All right, so this should be a pretty quick lecture today. I'm going to be covering databases. I spent, as I've talked about before, I've spent many years as a systems and data analyst. So these next two chapters, databases and systems analysis, are definitely within my my purview to talk about. So I spent many years with databases. So if you were here for the access chapter, you know all about databases. You know about fields. You know all the fields go into a table. You know we use the fields to create records. We've done all that already. That's the beauty of having this lecture after you've already taken the first chapter of access. So like a library, secondary storage is designed to store these databases, this information that's in the databases. We need to understand how that data is organized into fields, records, tables, and databases. And there are different types of databases and structures that you will find with different databases. I'll talk about that today. All right, this is not in your book, but I want you to understand the difference between the physical and logical views, but I'll get to that in a minute. So data are facts or observations about people, places, things, and events. And these can include audio, video, music, photographs, text, like all kinds of text, like letters and numbers. It can contain all of that. And there are two ways to view this data. And the reason I wanted to show you the difference between these two images on the right is because one makes sense to a lot of people. That's the bottom one. That's the logical view with the meaning and the content of data. As a regular person, let's just pretend I'm not an analyst. I understand words. I understand words like date, like month, like year, like region, like product description. If I'm not an analyst, I definitely want to see the logical view. The physical view is different. The physical view shows the format of that data and the location of the data. So here you will see like integers, floats, various characters, varchars. You'll see all the different formats of that data. Most people don't care about the format, they care about the meaning of the data. So today when I talk about everything, I want you to think about this as from the logical view and not from the physical. If you are a major big-time data analyst, you will deal with the physical view a lot. But the logical view is the one that we're going to be dealing with in this class. So data is organized into groups or categories. The 5 main items in this logical view are character. So when I type a letter or a number, that's a character. A field, that is a series of characters in a field, like last name, for example. I have to type a bunch of letters. A record, that includes a whole bunch of different fields. Now keep in mind, the book doesn't talk about this, a record can come from various tables. It doesn't have to be one table like we did on Thursday. On Thursday we created one table and we created records from that table. Coming up, we're going to be creating records from multiple tables. So it's possible for you to create somebody's record, and that record includes like last name, first name, employee identification number. In our cases, it's student identification number. Could include salary could include all kinds of information. Our address, that's another field. That can all be in our record. Tables. Tables are a series of fields. As we did on Thursday, we created a table with a bunch of fields in it. And last but not least, some databases have literally thousands of tables inside of them. Yes, thousands. And as the data analyst, you have to figure out how those tables link together, like what fields link the two tables together. And last but not least, and we're going to be dealing with this in Microsoft Access real soon, there is a field called a primary key field that we can set. So that means that every number, every word in that field has to be unique. It's a unique identifier. So it's called a primary key field. So usually I have the class do an activity. Hey. All right, so I know you're all by yourself over here, but I gotta come over here. You can see where I'm pointing. All right, so I just talked about the five things with databases. So what is this letter right here? What do we call that?
Rouse. R.
What is the R? I just talked about it. Character. What type of letter? It's a character. That is correct. What is list price? What are these? What are these? Field. Yes.
Yeah.
Okay. When all the fields are put together, we call that a
Table.
no.
Tab.
Record is correct.
Record. Yeah.
I have dashes around this first field. What do you notice about all the numbers in the first field? They're all what?
Sequential?
Okay, they are. But they're all different. Which makes this what kind of field? They talked about, they had a big bullet point at the bottom of the last slide. We call that the
Table?
primary key
Primary
field.
key.
So we all have different student ID numbers. That would be a primary key. Social security numbers, that'd be a primary key. That's a primary key field. Okay, now you can answer the question, what's the whole thing called?
A table.
Table. Now if I had a whole bunch of tables here, and I circled all of them, what would that be
Yeah.
called?
Database?
Database. Yes, I love it. Okay. It does kind of help that we went over this on Thursday, but yes, if you saw a whole bunch of tables at the top of that and I circled them, it would be called a database. Thank you very much. Okay. In this case, we only have one table, so the answer could be table. The answer could be database.
Yeah.
All right. There are two ways that a database gets processed. My favorite one is the second one of these and not the first one. So with batch processing, transactions are happening all day long, but the process happens at the end of the day, where the business is usually closed. In this example, somebody racks up a bunch of credit card transactions, and at the end of a certain amount of time, all those transactions get onto the statement. And we call that batch processing, where everything happens at one time. In my experiences, though, I like real-time processing. So when transactions happen immediately, we know when it happened, we know what the person clicked on, we know what the username is, we know all that stuff. And it happens in real time. I want you to think about your debit card purchases. Your money comes out immediately, right? It doesn't get held there. Okay. So databases themselves are a collection of integrated data. It's a bunch of tables. I want you to think about it as a logically related series of files and records. And I circled two items and made arrows on this on purpose. Because people ask me, why databases and why not spreadsheets? So databases address redundancy. That's like having several departments having records for the same customer or having the same file that they have to deal with. And it also takes care of data integrity, such as the accurate updating of files and records. So I asked this question before. Do people make mistakes with data entry? And the answer, of course, is yes. So databases actually allow us to run reports. I talked about this in chapter 10 with the decision support system. Allows us to run reports to see if errors have been made in data entry. My boss once asked me to create a report, and I did, and it contained 880 file entry mistakes. And he goes, can you print that out and take it to each of the employees and have them fix it? And I'm like, you want me to deliver that news? You want me to deliver that news to the employees? And he said, yes. And I said, okay. So yeah, it was great giving these employees these massive amounts of stacks of paper and go, hi, our boss wanted me to deliver this to you. And they're like, what is that? That's every data entry mistake you made over the last 5 years. He wants you to correct it as soon as possible. There must be 800 records here. I'm like, yep. They're like, you can't do it? I'm like, that's not my job. My job is to find this stuff. When my boss figured that one out, he was like, what else can we fix? Then he would just come to me every day and he's like, hey, can you create something for this and find the mistakes? I'm like, sure, I can find all the mistakes. So that's the great thing about a database, is having that in there. Sharing of data is really important as well. So in one of the major databases that are out there, people have usernames and passwords, and they can only see or edit certain parts of the database. Maybe you only have view access. Maybe you have the ability to delete records. How powerful is that? Okay, maybe you have the power to do various things in the system. I'll talk about that in a few minutes with database administrators and what their job is. Security, as I said, usernames and passwords, less data redundancy, and of course, data integrity. All right. So the database management system itself, as I mentioned before, allows us to put in fields. So this is, on the right, we're going to be dealing with this in the next project, and that is the design view in Microsoft Access. So it allows, and some of you have already seen this. So it lets you put in the field names, lets you put in the data types, lets you put in the descriptions, lets you put in the field sizes. So all the stuff we did in Datasheet view on Thursday, we're going to do in this on this Thursday. All right. So the database management system engine that none of us see, allows us to locate and search on data. This access data dictionary form that's on the right side, design view, if you will, this is what is called a data definition subsystems. There's a bunch of subsystems within Microsoft Access. This is one of them. We also have the ability to create forms using an application generation subsystem. We also have the ability to manipulate data using the data manipulation subsystem. Now, we are not going to be using structured query language in this class to search for records, but that is a technique that is used to search for data. But in Microsoft Access, it allows you to use query by example. And you'll notice on the bottom of this form, in really small word, it says search. So that's what query by example is. You type down in there for search, it brings up what you're looking for. It actually allows you to go through each record that contains whatever word you're searching on, which is really nice as well. I mentioned earlier that database administrators for major databases give us usernames, passwords, the authority to do certain things, access rights or processing rights. So that's called the data administration subsystem. So I told you there's a whole bunch of subsystems. I don't think you have to worry about that for quiz purposes, because I figured that was really going to confuse some folks. So that's why I didn't do that. All right. So all databases have what is called a database model. So database management system programs work with data that is logically structured, talked about that earlier, or arranged. We have 5 different models, which are the defined rules and standards for data within a database. And those are hierarchical, network, relational, multidimensional, and object-oriented. All right, so the first 2 are going to look somewhat the same. So you notice this one, you have a music library, there's a bunch of artists, the artists have a bunch of albums, and the albums have a bunch of songs. So we call this a one-to-many relationship. The parent has several child nodes. The nodes are points connected like branches of an upside-down tree. And there's one parent per node. So that's why we call this a one-to-many relationship. That's a hierarchical database. A network database, on the other hand, is many-to-many. You'll notice that a course can have several teachers, teachers can have several students, and you also notice that the pointers look like the hierarchical nodes, which you just saw a moment ago. So just keep that in mind that this one is many-to-many. Yes, you'll be tested on one-to-many and many-to-many. All right. The relational database. You notice that these three tables are all joined by a common field. Vehicle owners are at the top, vehicle table is in the bottom left, outstanding citation is in the bottom right. Now, being a person who's worked with a major database, I will tell you, sometimes the field names, notice how these are all license number, sometimes a table will have some strange field name, and that's where the license number might be. And you're like, what the heck is object ID? And you look at it, and it's the same number that's in the other tables, and you're like, well, why can't I join that? So I would try stuff like that, and it would work, because it's the same data in the same field. So anyway, you notice that the tables consist of rows and columns. I hope this looks somewhat familiar to you. I really do hope that this looks familiar to you. Hey, I'm on the TV in there. All right, this one I got to talk about for a minute. I'll be there in a minute. All right. So the next one I'm going to talk about is the multidimensional database. And you notice on the right, it looks like a cube. So a variation and an extension of the relational model to include additional dimensions is a multidimensional database. We also call it a data cube. One of your quiz answers today is this really massive word that's on the bottom left of this slide, and that is conceptualization. So with conceptualization and processing speed, it allows us to have faster querying than relational databases and data analysis. Now, some people will go, well, how do I know I'm using a multi-dimensional database? Now keep in mind, this would be like where you're logged into a website and you're asked to put in multiple requirements. You've got to like maybe pick something from a drop-down menu, pick something else from a drop-down menu, pick something else from a drop-down menu, and run it. And that's where you get this. So you notice that regions, time, and sales information all converge. Yes, all converge into the request for this data. Bless you.
Bless you.
And the last one is the object-oriented database. So I always joke about this one because notice that the objects are people's names. I hope we're not objects. Anyhow, all these people belong to a class called employee. There's attributes. Everybody has a first name, a last name, an address, a wage. And then there are calculations. So keep in mind that methods go well beyond just pay. We're talking like calculations for sick time, vacation time, any other type of benefit that's calculated would be called a method. But keep in mind, for quiz purposes, we are objects. We are objects. That's terrible. That's terrible. All right. Okay, which of the five? I gave it away already. Which of the five models does the Access database use? I gave it away. There's the one that I said looked familiar, should look familiar. You can do this. You can get this. I have faith in you. Which of the five? Remember I said we can build a bunch of tables in Access and join them all together? So which one would that be?
Database.
What was that? I thought I heard it.
Multi-dimensional.
Nope, not multidimensional.
Microsoft.
What was before multidimensional?
Microsoft.
No. I just talked about it. It was before multidimensional. It was the one where I had to run out of the room for a second.
I'd be guessing if I said anything.
Go ahead, you can guess.
Conceptual?
No, no.
Relational.
Relational, thank you.
Relation.
Because yes, the tables can relate to one another through common fields. That is what Microsoft Access uses. All right, other types of databases that are out there. So the database we created on Thursday, technically, that's just something we created. Like it's a database for ourselves. It's one table. So you can have many tables inside of an individual database, but that's usually just used by one person. Like let's just say that you wanted to create something in Microsoft Access and you wanted to use it for your own, for whatever you're gonna do with it. So, and if you didn't know, also, you can also create mailing labels with Microsoft Access. Yes, you can create and print mailing labels with Microsoft Access. And you can do a bunch of other neat things with it. Company databases, as the name implies, it's shared in an organization. Distributed databases are spread geographically using a database server, so people will log into it from different countries, different parts of this country, and it's called a distributed database. And last but not least is the commercial database, which I mentioned this before. Companies buy data. Why? Why do companies buy data? Why do companies buy data? It's so that they don't have to do what? I'll let you think about that for a second. Come on, we're almost done. Watch me get up there. Why do companies buy data?
Why do companies do what?
Why do companies purchase data? So
Oh.
that they don't have to do what? This is an easy one.
They don't have to do advance.
They don't have to do it themselves. Yeah, they don't have to spend the time to collect it themselves. So there are commercial databases that are out there, like CSI, Dialogue Information Services, Dow Jones, etc. There are a lot of data banks out there, and there are a lot of free data banks out there as well. But that's what we call commercial databases. All right, we're actually nearing the end of this, so if you're just joining us, yes, I decided to cap the extra credit for the people who've been earning it. So I'm going to, yes, give you another bonus, but it won't be like as much. But anyhow, I'll determine that. So here we go. So my wife always wondered what I did for a living, and I would always tell her I'm off to the mines every morning, because I did a lot of data mining inside of our data warehouse. Now keep in mind, a data warehouse can contain many different databases. So remember, I've only been focusing on a singular database so far, but now we're talking about a bunch of different databases, all in one location. We call that a data warehouse. And then to get the data out of those databases, we perform something called data mining. And that's literally what I would be asked to do on a daily basis. Nick, can you go find this for me in our database? Which resulted in me wanting to know everything about the database, like everything, like every field, like the usernames, the passwords, the embezzlement that was occurring. I found all that stuff. And yes, I did mention that my work has resulted in the resignation of at least three college presidents that I know of. It's probably likely more, but there's 3 that have at least been documented in the newspapers. So I'm telling you, if you get really good at data analysis, you're gonna be asked to do and people find out, they're gonna ask you to do really neat stuff. But keep this in mind. I mentioned the usernames and the passwords, so how valuable was that? Like the unencrypted usernames and passwords, how valuable is that to an organization?
Very.
Yeah,
Very.
could I have sold that for probably a boatload of cash? Yeah, but I'm ethical, and that's why I'm still here. So anyhow, databases are extremely, extremely valuable. And sometimes, if you think about where these servers are located, your username and password, that's on your end, or multi-factor authentication, that's on your end. But what about the actual servers themselves? Like, we need to have those protected. Like, protection has to be necessary, like physical, like biometric protection, badge protection, all that, key protection. We need that. We need those. Otherwise, somebody can just go in and take our stuff off the physical server and go, I got all the data now, and walk right on out of there. It scares me to think about that sometimes. But anyhow, as I told you in this class, I'm going to try to provide as much awareness as humanly possible. That's my job. Well, here's a shocker. Today's career in information technology is the database administrator. Oh, okay. Just wanted to check to see if everything was okay. All right. So, database administrator, I mentioned this earlier. That person is responsible for granting access to certain parts of the company's system, assigning roles in the system. They're responsible for, not every database administrator is responsible for backing up the system. Usually IT does the backups. Somebody else in IT does the backups of the systems. But they're definitely there to recommend types of security and ways to back up the system. So employers do look for bachelor's degrees and technical experience. And you see how much that they make. Now, some database administrators, it depends how large the organization is that you work for. Some are on call literally 24 hours a day. Some work 16 hours a day. Some work 8. It just depends what type of organization you get yourself into as a database administrator. I actually thought the job was really neat when I was doing all the analysis, because I had to talk with these people. I had to talk with database administrators all the time, because they're the ones that showed me how the tables linked up, and they gave me all the resources I needed to figure out how every table in the system, all 1,000 of them, linked up to one another. I'd seen major diagrams, and I'm like 5,000 page manuals, and I'm just like, this is a lot. Like, I don't think anybody even knows what this system does. And it took me a long time to figure that out. But the good news is, I figured out that there were a base set of tables that were in the system that impacted our accounting office, our purchasing office, our accounts payable office, our capital asset office, all those different offices. I figured out that there was just a base set of tables that I could use and go from there to create whatever they wanted me to create. Anyway, they make a lot of money. And then look to the future for this chapter. Can criminal behavior be predicted? My argument is,
Yes.
my argument is also no. What if nobody's ever done anything before? And then all of a sudden, bam. So in cases like that, it can't be predicted. But you are correct. It can be if there's a pattern, or if there's, yes, absolutely, it could be found. But yes. All right, everybody online. Hey, I want to thank you all again for the over 100 subscribers now. Thank you very much for that. We are going to continue with Access on Thursday, and we are going to be working with the design, my favorite view, because we can put things in a lot faster there. We're going to deal with the design view on Thursday. Well, thank you all for being here once again. I told you it was going to be a short one today. Once again, thank you for subscribing. Thank you for watching. And I got you, my one chat person in the chat. Don't worry, it's all good. There's like less people here today than usual, so it's all good. All right, everybody, take care. See you later.